Hello, this is Math60 at Lane Community College. My name is Angela Martinek. I am an instructor here, and this video is about real numbers. So what we're going to do is actually build the real numbers. We're going to start with what are called natural numbers. Natural numbers are natural in that they start with the number 1. Just like when you're learning to count, I'm going to try and draw. We'll see how I do. Tiny little finger, but when you're learning to count, you use your fingers, right? And you start with the number 1. Little kids will say, oh, 1, 2, 3, 8, 12, and they go on like that, right? But they start with the number 1. Natural numbers are integers. They're whole numbers like this. They're not really whole numbers, but they don't have any fractional parts, right? 1, 2, 3, things like that. If I were to take all of these numbers and stick them into a bag, so I'll just tie a little knot around that bag, and I were to place these in here, so I stick in a 1, a 2, a 3, a 4, and I keep going and I keep adding all these numbers to the bag. What I have is a set. In mathematics we would call this bag a set of numbers, or in this case the set of natural numbers. And mathematically I would write it with curly brackets. So I'd have a curly bracket, 1, comma, 2, comma, 3, and I'm just listing those things that are in the bag, that are in the set. And we would keep going. We can keep going to 2 million if we wanted to, if we had the time. So I say dot, 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 as if we go on forever. And this is a set of natural numbers. That all works well, and then we think, well, what if I didn't have 1? How many do you have? Well, I have 0. 0 is not a natural number. 0 is like a whole in a sense, and we add that to the natural numbers and we get what we call the whole numbers. So whole numbers are oops. Well, I guess it does work. All right, I'm trying to highlight these. So we have natural numbers, which are 1, 2, 3, 4, 5. We have whole numbers, which start at 0. Okay. Now, that's great. That works well. Whole numbers, for the most part, look good on a bank account, right? But let's say I had $50 sitting in my account, and I took out $75 before they realized I was trying to take out more than I had. Well, I'd be in debt $25, right? There'd be a kind of I'm making this subtraction, but I'm sort of in the hole $25. And the way we write this in mathematics is instead of saying I'm in debt $25, I would say I have minus $25. This becomes a negative number. It's something that, in terms of a bank account, we want to stay away from. In actual accounting, sometimes they use parentheses instead of the negative. But for mathematics, in our study of mathematics, we're going to look at these numbers as negative. If I combine these negative natural numbers with the whole numbers, remember the whole numbers started with 0, then went 1, 2, 3, etc. If I now say I can add negative numbers, I'm going to move those over here and say -1, -2, -3, and I could keep going in this direction as well. If I take a look at this set, this becomes a very important set in mathematics, and it's called the integers. So we have whole numbers, natural numbers, and integers. Great. However, we've been studying numbers that look like 3/2. We've looked at 1/3. these don't fit into these integers, right? 1/3 is not an integer. It has a numerator, a denominator. It's almost a ratio between two numbers, right? A over b. We want to make sure that b does not equal 0, however, because we can never ever divide by 0. All right, so if I have a number that looks like the ratio of two integers, we give that another name, and we call it a rational or rational number. Right? So 3 is an integer, 2 is an integer, and then we have another set of integers, another set of numbers called the rational numbers. Now an integer, remember, could be negative, so a rational number could look like -3 divided by 7, something like that. So let me see if I can draw a little picture for you. We started with the natural numbers. So I'm going to call these the natural numbers. And then to those natural numbers, we added the number 0. And when we did that, when we added 0, we got something that was all of these natural numbers plus 0, and we called these whole numbers. Right? Because we added 0. Then we added negative numbers, so we added more numbers, except now, so we've encased all the natural numbers, we've got 0, and now I'm going to add in negative numbers. Right? It's like -2, -1000. Got all these negative numbers sitting out here now, and we called these integers. And then we put in fractions. So we put in 1/2. We threw into this bag 3/7. We have -2 over 5. All of those types of numbers. So we stick all those in the bag. So our bag is getting bigger, our set. And now we have these rational numbers. Well, wait a minute. Are the natural numbers rational numbers? Can I write an integer, say 5, which is an integer? It's also a natural number. It's also a whole number. Can I write it as a ratio of two integers? The answer is yes, because I can write this as the integer 5 divided by the integer 1. So it turns out, yep, all integers are rational numbers. Great. We do have one more type of number. Well, we actually have several, but one we're going to talk about here, we're going to add in irrational numbers. Things like pi, the square root of 2, things that cannot be written as the ratio of two integers. Pi cannot be written as the ratio of two integers. So these are irrational. All right, so if I take all of these and I dump them into a bag, a very large one, right? I put them all into this bag, tie it here with a nice little bow. What I have here are what are called the real numbers. Okay, so the real numbers have been built from all of these other numbers, lots of them. There are many, 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 in fact, infinitely many real numbers. Okay, let's look at some examples. The number 2, that's a whole number. It's an integer, right? How about the number -1/2? That's a rational number. It's rational because that also could be written as -1/2 or 1/-2. We'll see that later. What about the square root of 3? Well, that's irrational. How about the square root of 16? That's rational. It's not only rational, it's an integer. Because the square root of 16 is equal to 4. Right? Because 4 times 4 is equal to 16. So if you put the square root of 16 into a calculator, or you know that the square root of 16 equals 4, you see that this is an integer 4, which could also be written as 4 divided by 1. So we can classify a lot of these numbers. Now the next video, we're going to look at ordering the real numbers.